Good afternoon. Maths, are you there? So today we are going to discuss what we call the ballistic pendulum. Ballistic pendulum. And this is a device that can be used to measure the speed of the bullet. Whereby, Mercy,
Yes, please, teacher.
where are the rest? You ask them to come from the group as I draw the diagram. So according to this ballistic pendulum, it is used to measure the speed of the bullet. If a bullet is shot to a block, and you let the block have a mass, capital M, and then the bullet have a mass, small m, then momentum conservation before, and the bullet would be having a velocity u. Then the block was initially at rest. So this has an initial velocity 0. This has an initial velocity u. So momentum conservation, the bullet initially had momentum mu plus the block, which is capital M, having initial velocity u prime. Because of momentum conservation, which is inelastic, because they get stuck together, we shall have small m plus capital M. Immediately after collision, they move with a common velocity v. When they move with a common velocity v, this is what we shall expect. Small m u plus 0 is equal to capital M plus small m times v. So the velocity with which they move with after collision is mu out of capital M plus small m. Then we have energy conservation. Immediately they have collided, they gain kinetic energy. So the kinetic energy after collision is going to be equal to a half times capital M plus small m times the velocity v squared. Then they will lose the kinetic energy and gain potential. After displacement, the potential energy gained will be mgh, which m is m prime, which is capital M plus small m times g times h. Now, because of energy conservation, the kinetic energy is going to be lost, and we shall gain potential. So the potential which has been gained is resulting from the kinetic that has been lost, and with that reason we shall have capital M small m v squared is equal to capital M plus small m gh. We can lose the sum of the masses, and then the velocity v squared is equal to 2gh. Therefore, from here, we can find capital V as square root of 2gh. And when you get capital V, you can substitute it back here and find mass of the bullet, velocity of the bullet from mu is equal to capital M plus small m times V. So initial velocity of the bullet is capital M plus small m times root of 2gh divided by mass of the bullet. So we can get it from this expression. So that is the expression we can use to find the mass, the velocity, initial velocity of the bullet, just in case it has been asked for. And let's see if someone has a question. Any question? Hello, any question about those derivations?
No.
Okay, let's take a look at an example. So here we are in those notes I sent. This is how the ballistic pendulum looks like. Just like I've been trying to relate and show you how the derivation has come about. You can see that sometimes if they don't give you the height, you can be in position to find it from here. How? By, say, for example, if you look at this illustration, you can extract out this height in this form. That because initially, we had seen that if it was initially here, the block, then after collision, the block rose to this height with a bullet. Now, if you're looking for this height and you don't know it, but they gave you the length of the string. So the length of the string also initially when it was at rest was L from up here to down here. So if this is theta, this is 90. Now this distance here is going to be L cos theta. When you resolve this distance, this is L cos theta. So when that distance is resolved, and you get it as L cos theta, it means from here up to here, the distance is L cos theta. But L cos theta plus the height is going to give us the total distance L. So the height can be got from L minus L cos theta. So, because I've already showed you how we have derived, because I already showed you.
I thought that distance is L, not L cos theta.
When you resolve it is L, not L cos theta.
Because it's the length of the string to the mass.
The body, to the block. Yes. Okay. Now, until now, if this was the bullet initially, and this is the block, the total distance from up here to the block was initially what? L. If it was initially L, would I consider from here up to here, when there has been a displacement of the block to this height, the distance from here up to here is L cos theta, this one. But L cos theta plus this H gives us the total distance vertically, which is L, which is the length of the string. I don't know if I've made sense.
Yes, thank you.
You're welcome. So remember I derived, okay, they have explained here. Remember I derived this equation. Eh? So we can have this as U is equal to the mass capital M plus small m times square root of 2gl into 1 minus cos of theta over mass of the bullet. So when you substitute for H, you substitute L minus cos theta, which is this one. So sometimes they can even ask you for the angle of displacement. Eh? Then you extract out, when they ask you for the angle, you can see that from V or from U is equal to root of 2gh, which I derived. You will say that U squared is equal to 2gl into 1 minus cos of theta. Then you realize that U squared, okay, you realize that U squared over 2gl is equal to 1 minus cosine of theta, and you can make cosine of theta the subject, which is going to be 1 minus U squared over 2gl. So theta becomes cos arc of 1 minus U squared over 2gl. So that gives you the angle which the displacement has realized as a result of the bullet striking the wooden block, and then they get displacement or displaced up to that height. So those are the derivations for the ballistic pendulum, and those are the definitions that define a ballistic pendulum. So the notes are right here. You can have them down. We are left with looking at some examples concerning this, unless if someone has a question. So here is an example. Marcia, can you read this question? And take a screenshot. I want to go and use the white page. Marcia, read the question.
A bullet of mass 20 grams traveling at a speed of 200 meters per second embeds itself in a block of mass 980 grams suspended by a string such that it swings freely. Find I, the vertical height through which the block rises, I, how much of the bullet's energy becomes internal energy.
Okay. Now, we shall have to go and use the other page. Let's use the other page. We are seeing that they have given us, now one of the challenges of this number, they give the mass of the bullet in grams. They give the mass of the block in kgs. And the people fail to convert for the block, for the bullet, which is another troublesome event, whereby when you fail to interpret that and just use grams throughout, you'll get wrong solutions. So we have our bullet. Mass of the bullet, small m, is 200 grams. Mass of which is 0.2 kgs. Capital M, what is capital M? Capital M has been given as 980 grams. Capital M is 0.98 kgs. The string, have we been given its length? The string has a length we don't know. They only told us it was free to move and even gave us the speed of the bullet. This time around, they're not asking for the speed of the bullet, but rather they gave it to us. So they gave us U. This one was initial at rest. Then they are going to rise into a height. We can find actually everything just for the gist of having this discussion. We can find everything and we see how to get them. They never gave us L. But initially, momentum conservation. So for momentum conservation, the mass of the bullet times the initial velocity of the bullet plus zero momentum for the block is equal to their total momentum after collision, and we shall have a common velocity V. So V is going to be mass of the bullet, momentum of the bullet over the sum of the bullet and the block, which is 0.2 times 200, because the initial velocity was 200 meters per second. So times 200 divided by 0.2 plus 0.98. Actually, this was supposed to be, the bullet was 20 grams, not 200. Yeah? The bullet was 20 grams. So if it was 20 grams, it is 0.02. So 0.02. So this will give us 40 divided by 1.0. So the common velocity after is 40 meters per second. The question says, how much vertical height through which the block rises? So the block is going to rise, we need to look for H. Remember, we said H can be got from what? Energy conservation. So kinetic energy before, we said is a half m plus capital M times their common velocity they have moved with. Then potential energy gain is equal to capital M plus small m times G times H. Because the energy is conserved, we shall have half capital M plus small m times V squared is equal to capital M plus small m times G times H. I lose this with that. Then I can find H from half V squared out of G. This will give me half times 40 squared divided by 9.81. Calculator, what is the height? If we get the height, we can even find the length of the string. We are going to see all of them. We're going to get everything. Even the angle. Hey, no, we don't have the angle.
$81.5494.
81.5455 meters. Then the question said, how much of the bullet's energy becomes internal energy? Now the bullet's energy, we need to first find the total energy the bullet had before. Then after collision, we find the total energy. So the difference in energy becomes what we call the internal energy. So with that regard, we shall have kinetic energy of the bullet before is equal to half times small m times its initial velocity, which gives me half times 0.02 times 200 squared. What is this energy? That is 40,000, which will give me 400. If that is 400, then what is the energy after for the entire system when the two have collided? So the difference in that energy within this one and the other will account for the internal energy of the bullet. So kinetic energy after collision is equal to half capital M plus small m times V squared, which is going to be half times 0.98 plus 0.02 times the velocity squared. What is the velocity? Velocity we attained 40 squared. What do we get? Wait, was the velocity 40 or 4? Because this value is very big. Guys, check this calculation. I made a mistake. This was 0.02. That's why these values are big. I was wondering. This was 0.02 times this, you get 4. So this is 4.0. So get 4.0 squared. When you get 4.0 squared, you must be getting 8.2 or 8.15. Confirm with the calc. So the height is 8.2 meters. So if this is 4.0, you can assume this is 4 squared. So what answer do we get? Because the reason why I was worried, we are getting energy greater than the energy before. Yet actually the bullet has lost some energy because it is stopping to move. Yeah?
Eight.
You get what? 8. So the difference in energy accounts for the internal energy of the bullet. Therefore, 400 minus 8 will give me 392 joules. Is the internal energy of the bullet. So we can have that down. Let's have one example. There are these 12 questions. There are 4 of them. Let me do number 3. Then the other 3 are yours. They even have the answers right there. So it's your job to investigate them. Let's have Annie. Cynthia, you're reading for us question 3.
A bullet of mass 40 grams is fired from A bullet of mass 40 grams is fired from a gun 100 meters per second and hits the block of mass 2 kilograms, which is suspended by a light vertical.
Oh, who is looking for you?
Yes, sorry. A bullet of mass 40 grams is fired from a gun at 200 meters per second and hits the block of mass 200 grams, which is suspended by a light vertical string 2 meters long. If the bullet gets embedded with the wooden block, calculate the maximum angle the string makes with the vertical and state the factors on which the angle of the swing depends.
So this is 2 cos theta. This is the height. The bullet was moving. The initial speed of 200 meters per second. So initially, mass of the bullet plus 0 momentum for the block. Here now the bullet has been embedded is equal to their momentum after immediately they have collided. You can find the initial velocity after collision from mass of the bullet, which is 0.04 times 200 divided by the mass of the bullet is 0.04 added to the mass of the block. The block was given as 2 kgs. Be very sensitive whenever they give this in grams and this in kilograms. People just add, then they will get 42 kgs. So velocity will become 8 out of 2.04. What is the velocity after they have collided?
3.92.
3.92 meters per second. So that is the velocity immediately after they have collided. So they're asking us to find the angle. But remember, we saw that the velocity gives us 2gh under the root from energy conservation, and h is equal to L minus L cosine of theta. So v squared will actually be equal to 2g L into 1 minus cosine of theta. So the velocity is 3.92 squared is equal to 2 times 9.81 times 2 into 1 minus cosine of theta. 1 minus cosine of theta would be 3.92 squared divided by 4 times 9.81. What is cos theta? Theta is cos arc. And clearly we can see that the angle of swing, if you can get on what it depends on from here by saying, remember we derived the cos theta as equal to 1 minus v squared over 2gl. So it depends on the following. 1, length of the string. 2, acceleration due to gravity. Then 3, velocity after collision with the block. Collision of the bullet with the block. So those are the main dependents of the angle of swing.
Theta is 52.5.
Theta is 52.5, which is approximately the same as that. Okay. So that number, I think you can take a screenshot so we can have the numbers. Those 4 numbers. Today you're only 2 guys. Why don't you first try out for me number 1? Okay, if I can proceed. Try out number 1. So the other new definition, which is balls striking on the wall, water splashing on the wall and back. I think that one I discuss it next time because you only two and I introduced two new things. People will have missed a lot. So, but if they don't show up, I'll have to finalize momentum next week, whatever the case. So we are left with water splashing or a ball bouncing, water splashing on a wall, which is following here next. Look at this right up. Force on a surface. Then we have at an angle. The other one was perpendicular. This one is at an angle. So for those of you, for you guys who have been here, you come and you break through somehow, so that when I try to go through them, you're not having so much challenges. So finish that number 2 and present to me your solution in the WhatsApp. I want to see. You present it on the group and I see you right up so that those ones who have missed see how you guys are enjoying the numbers. Okay, so let me close this now so that I don't waste much of your data. I'll be waiting to see you right up in the WhatsApp group.
I can take a screenshot.
Okay. Actually, for all the numbers, you can do all those numbers now, by the way. I want the screenshot for what?
I'll finish.
Okay.